I thought this experiment would end with a workout plan. It didn't. It ended with my own Android app.
I walked into my apartment gym and took 8 photos. That's it. I just wanted to see if AI could figure out what every machine did and build me a workout plan around the equipment I actually had. I had no idea that a few hours later, I'd be holding a fully working Android app on my phone without writing a single line of code. This is how one simple experiment turned into something much bigger. There was a reason I wanted to try this. I'm 49, and after spending more than 2 decades behind a desk, my upper back and neck aren't exactly in great shape. I wanted to get back into training, but I didn't want a generic workout plan, and I definitely didn't want to guess how to use every machine in my apartment gym. I could have hired a personal trainer, I could have downloaded another fitness app. Instead, I wondered, could AI build something that was actually made for me? Step 1. I went down to the gym in my building. I just took photos of every machine, about 8 photos in 5 minutes. Then I came back upstairs and opened the Genspark default agent on the homepage, not AI chat, not code, the orchestrator. It picks the right tools for you. I dropped all the photos in and asked one thing. I'm at the gym. Please identify every machine you can see, list each one, and explain its primary function, including the main muscle groups it targets. Watch what it does. 11 distinct pieces of equipment across my photos. For each one, name, primary function, muscles targeted, and the killer detail. Every identification links back to the exact source photo it came from, so I can verify every claim. Machines separated from accessories, medicine balls, kettlebells, a Swiss ball listed on the side, and at the end, it offers me a step I didn't ask for. If you want, I can turn this into a complete gym equipment audit with beginner to intermediate use cases. But here's what surprised me. Before writing a single exercise, the agent launches a parallel search. Watch the right panel. It's not making up a program, it's pulling ACSM guidelines, American College of Sports Medicine position papers, low back pain, rehabilitation research, live right now because I mentioned my chronic pain. Look at the dates: March 17th, 2026, March 18th, 2026. These aren't papers the LLM remembered from 2 years ago. This is evidence-based generation. The agent is grounding my program in the actual current sports medicine literature before it writes a single set of reps. This is the anti-hallucination piece nobody talks about. Cursor writes code from its training data. Bolt writes code from its training data. Claude and ChatGPT answer from their training data. Genspark actively queries fresh sources, including papers published 48 hours ago, before it writes. Now watch the payoff of that parallel search. Every single major recommendation in the program links back to the source it came from. WHO for the weekly activity minimum, CDC and NHS for movement targets, American Family Physician for chronic low back pain treatment, Mayo Clinic for neck rehab, AAOS, American Academy of Orthopedic Surgeons for spine conditioning warm-ups. 6 inline citations across a single response. This isn't an LLM guessing. This is a program grounded in sources I could hand my doctor if she asked. 24 weeks, 4 phases, workout A, B, C, plus an optional D, deload weeks built in every 4th week, an RPE intensity scale so I don't grind myself into the ground, green, yellow, red pain rules, literally telling me when to push, when to back off, when to stop and see a doctor, a desk damage correction section that names my exact problem: too much sitting, too much pushing, not enough pulling, and posture work. This is what a strength coach with a rehab background writes, not what an LLM makes up. If you want, I can turn this into a clean, printable weekly sheet with checkboxes, exact loads, reps, tracking columns, and a one-page gym version you can use on your phone. And at the end, same pattern as the inventory, it offers me the next step I didn't ask for. One click. Yes, now the agent routes to AI docs and turns the whole thing into a print-ready document with checkboxes and load tracking columns. One conversation, multi-tool orchestration, 0 context lost. I can bring this to the gym on my phone or print it and stick it on the fridge. At this point, I was really happy with the outcome. But then I noticed that Genspark had just released a new feature called Design/Prototype. That got me thinking, how far could I push this experiment? Could I take this 24-week workout plan and turn it into a fully designed mobile app? Attach the program from step one. And I typed 12 words, not a 5-paragraph brief, 12, same lesson as step one, prompt like a human. Watch what it does. First, it doesn't touch a pixel. It downloads my program file, extracts it, reads the whole thing. 5 sections. Click, don't type. Every choice narrows the design direction before a single mock-up gets rendered. This is the anti-hallucination pattern applied to design. Instead of guessing what I want and burning credits on a bad first draft, the agent gets alignment first. Cheap. Material 3. Dark mode. Data forward. Today's workout is hero. Multi-select on the screens I want mocked. 30 seconds of clicking. Submit. This is what came out. Not a template, not a bootstrap knockoff, a custom design system named Stack. Instrument serif for the numbers because data is the hero. Enter for the UI. Near black surfaces with an electric lime accent because gym lighting is glary. Snappy motion, no bounce, because this app is disciplined, like the program. And the tone line, I did not write this. The agent wrote it direct. No gamification slop. It pulled that vibe straight from my program document. That's personalization plus multi-conversation context awareness working together. Toggle in the corner, all screens on one canvas, or a single live prototype. Watch this. This isn't a static Figma export. The steppers actually work. The state persists to local storage. I can tap through the entire user flow, mark a set complete, watch the counter update before I write a single line of Flutter code. And look at the greeting. Ready, Roberto? The agent used my name in the mockup. Personalization pulled from my profile. Same feature that gave me evidence-based citations in step one. It's not just multimodal. It's contextual across the whole workspace. One button, top right corner, build it. That's the handoff. So before I actually click build it, let's see how many credits it takes to generate a fully functional Android app. At this moment, I have 73,118 credits remaining. Let's find out how many of those credits Genspark will use to turn this 24-week workout plan into a real mobile app. New conversation opens, and I didn't type this prompt. The design agent generated it automatically, cloned the design repo, referenced my original 12-word request, 0 rebriefing, same context, same workspace. Now I speed this up because it's a lot. Watch the file tree grow. Flutter Dart files being written for every screen. Real code, not mockups. Watch the app icon getting integrated across every Android screen density, MDPI, HDPI, XHDPI, all the way to XXX That's actual Android tooling. Watch the signing tool verify the key store, then the final Flutter build apk release command runs. This is not AI slop code. This is what an actual senior Flutter dev workflow looks like. And here's the moment I knew this wasn't a toy. Straight talk, the agent's own words. It tells me my APK is heavy, 45 megabytes, and explains why. Flutter bundles the Canvas kit renderer plus self-hosted fonts. Then it offers me 2 optimizations, split per ABI to cut each build to 15 or 18 megs, or an Android app bundle for Play Store distribution. This is a senior dev conversation, not a vibe coding tool, not AI slop, an actual engineering trade-off explained in plain English. Look at the build metadata. Package name, com.stackfitness.fitness, version 1.0.0. Target SDK35, that's Android 15 latest. Signing, release key store, verified. Not just auto-generated. Verified against the Gradle config before build. Ready to sideload. Ready to sign my own key later if I want the Play Store. Tap. Android asks, install from unknown source? Yes, it's mine. Installed. New icon on my home screen. The icon Genspark generated for me. Open it. Ready, Roberto? Same greeting as the mock-up. Tap a set, checkmark, swipe, next exercise. Close the app, reopen it. State persists. This is my actual phone right now, not a simulator, not a screenshot, a real Android APK running native, signed, installed from a two-conversation workflow. A few hours ago, this started with 8 photos of my apartment gym. I just wanted to know if AI could understand the equipment I had. A few conversations later, I had a personalized 6-month workout plan and a fully working Android app running on my phone. Honestly, I still find that kind of hard to believe. The entire experiment used 38,347 Genspark credits. On my Plus annual plan with the Enterprise bundle, that's roughly $22 worth of credits. On the standard Plus annual plan, it's closer to $70. Either way, we're talking well under $100. Building this with a traditional agency would likely cost somewhere between $10,000 and $20,000 once you include the workout program, the app design, the Flutter development, and a signed Android build. But here's the part I'm thinking about. This wasn't really a fitness experiment. It was an experiment in what's possible. If 8 photos can become a workout plan and a mobile app, what else can AI build? That's exactly what we're going to find out. I'll see you in the next experiment.